Okay, obviously, like I think probably everybody who's speaking in this, I'm speaking in part, not on behalf of other people, but thanks to the efforts of a whole bunch of other people. And some of the people you can see in the slide there, that was from the field program we ran a few years ago at Nar Lake, which took the record there back now to 14,000 years ago. And some of the funding bodies who helped us with that, but also just a couple of other people, and you can see Matt Jones and Warren Eastwood and Fabien Arnaud and various other people who are involved in that. But I'd also just like to say a special thanks to Catherine Kuzujoglu, Henk Voldering and Walter Dörfler for sharing some pollen data, and also to Peter Kuehneholm. He may not actually agree with what I'm saying, but thanks anyway to him when I talk about some tree ring data a little later. So if we're asking some overall questions at this meeting, it's questions like, did climate change influence Bronze Age civilizations in the Mediterranean, both their rise and especially their fall? And if they did, how did they do so? And I think we'll probably come to some vague conclusions that in some way they did, but we're not entirely sure how. But also I want to ask a second question, looking forward, is how far we can adopt approaches and sources of data that might us help understand that relationship a little bit better in the future, the relationship specifically between cultural change and climatic and environmental change. So the talk I'm going to give will start with a little bit of climatic context, and then I'll say something about central Anatolia, something also about southwestern Anatolia before making a few wider regional comparisons and also well, it sounds rather pompous to talk about explanatory models, but some broader issues about how we can both understand the relationship and also maybe improve our understanding. So if we're talking about climate, we're talking about data like this. These are some stable isotope data from a drained crater lake in Cappadocia in central Turkey, Eski Acıgöl. The climate data are actually pretty good. The chronological control is not so good in this case, but the point I think we can see there is that even if you move the dating around by a few hundred years, which you almost certainly could, what you see there is a trend, first of all, from generally rather wetter conditions in the mid-Holocene, say 6,000 years ago, down to a period of essentially maximum aridity, maximum dryness, at around 3,000 years ago. That kind of 3,000-year time frame is shown there. But you can also see that the evidence is that long-term decline in precipitation, which I think is probably a fairly general trend across the region, was not a linear trend, but one involving oscillations of climate, cycles, in this case of about 100 to 200 years in length, of wetter and drier conditions. So the precise timing of those events is a matter for debate. Was it, for example, maximum aridity 1200 BC, 1100 BC, 1000 BC? I think records like this probably can't help resolve that, but I think they can say that they were cycles of quite substantial amplitude, and that they weren't of equal length, all the cycles either, but they were variations through time which would have had significant impacts in terms of societies needing to adapt, or if not, if you don't adapt, then obviously you can end up with a crisis. So there's a series of what one might think of as mega droughts, extended periods of dry climate within an epoch, and that period from perhaps 4,200 years ago to the middle of the first millennium BC, in our records at least, comes out as the driest overall period of the Holocene. It wasn't uniformly dry, but overall that was civilization in many ways emerged. Some of the complex civilizations emerged not because of improved environmental conditions, but in a way in spite of climatic adversity. And the late Bronze Age, and that chronology you would fit in there. So that's one record. We can then take and fit them together as Martin Finet and Karen Holmgren did, and I'm sorry if I'm stealing a slide which you may well see again from Martin later on, but essentially that shows more or less the same thing when you take not one record but all the available data, in this case from the Eastern Mediterranean, and pull them into 200-year time windows. You can see many of the same drought episodes. You can see suggestions that there was not only a longer-term trend, but also oscillations between drier and wetter conditions over that time period. And when we put this and Ilko showed a version of this earlier on. If you compare those drought cycles, which are on the, let's get the right way around, which are on this side here, against simple archaeological phases for different regions of the Eastern Mediterranean, Greece, Egypt, the Levant, Anatolia, and Mesopotamia, if you simply take those divides, when was the end of the Chalcolithic and the beginning of the early Bronze Age, when was the end of the late Bronze Age and the beginning of the Iron Age, then the timing of those archaeological periods essentially coincides within the limits of our chronology with these periods of climate oscillations between dry and wet. And in particular, archaeological transitions coincide very broadly with these periods of what we might call mega droughts. So there is quite a sort of, that's that broad synchronism between cultural changes and climate does suggest that there's likely to have been some relationship between the two. It doesn't say what that relationship is, but it says that there's likely to be some relationship. So I think in a way, the question may not be whether climate influenced the rise and the fall of Bronze Age civilization, but how it did so. Because if you look through that, not all the climate changes that we see in those records had consequences for society. Some societies were more resilient to climate change than others. Those responses to society were not predictable in advance. In one group, drought could prompt collapse, but in others, it could actually prompt innovation. And I think Arlene Rosen has done some interesting work on that, in particular for the early Bronze Age in the Levant, showing how the climatic crisis, if you want to call that, around the 4.2K event, 2200 BC, in some cases led to temple building. So one potentially logical response was to appeal to God and pray harder, and that would solve your problem. And some other groups went out and developed irrigation. Okay, now with hindsight, we can see pretty obviously which was the more successful choice, but it was probably not obvious at the time. Yeah, okay. So there are within this quite clearly human choices, and that applies to societies in the past just as it applies to our society today. We've got choices about how to respond to climate change. If we want to move on to real explanations about how climate may have affected society, then providing real demonstrable evidence for causation is not easy. Yeah? In a way, our most authoritative evidence for that probably comes from multiple sources, but the clearest evidence, if we can get it, is going to come from texts. Yeah? But we're only really at the period in history when textual evidence is beginning to be made available. Within the late Bronze Age, it's extremely patchy. Our best evidence obviously comes from Egypt. We have some evidence from Anatolia. We have effectively no evidence from Greece. I mean, the Mycenaean texts don't tell us about drought and famine, and indeed in the case of Crete, we haven't in Linear A, we haven't even been able to translate it. So we do have some textual evidence, which I think is informative, but for this time period, it's relatively incomplete, and therefore the evidence is relatively weak. So in the absence of that, then what do we turn to? We turn to temporal correlation. We rely on the well-tried and tested scientific approach of looking at synchroneity between potential causes and potential consequences. But if we're looking at temporal correlation, did things happen at more or less the same time, then that in turn takes us on to dating. And therefore, that takes us inevitably onto the reliability, both the precision and the accuracy of radiocarbon dating. And I think we have to be honest with ourselves here. I've put up a radiocarbon date there of 2962 plus or minus 14 BP. Anybody sharp-eyed among you know what that represents? Maybe Eric can tell us. Do you remember what that is? That's the pooled series of radiocarbon dates from TEL 20. I'm not sure actually about the statistical reliability of pooling dates, but anyway, if you do that, but if you calibrate that to two standard deviations, you come up with, those are the ranges, 1123 to 1223. In other words, precision of 50 years. So I'm not sure how you can actually, on the basis of that, and that's the calibration. And you can see there's the radiocarbon age, and those three different periods when it intersects with the radiocarbon calibration curve, well, you tell me which one's correct. I think it was suggested, I think David Kaniewski suggested it was between 1192 and 1190. So not sure how you get to that, but well, okay, all right. I mean, there were other sources of data that he was using as well, but I think we have to be honest that if we're using these kind of chronologies, we're probably talking about a multi-decadal time resolution. We're not time precision. We're not talking about annual in the vast majority of cases. So I mean, I think we all agree about that, but I think it's important that we don't forget it. Okay. So with that as a kind of introduction, I'm now going to say something about Anatolia, firstly about central Anatolia, which of course was the home of the Hittite Empire in the second millennium BC, and I've just sort of superimposed on the Google Earth composite data the area that was broadly occupied by the Hittites, and along with the weather and crop god Teshub there. And obviously there are a number of important sites, urban sites, which we have for that time period. I mean, most famously at Boaz-Kai, Hattushash, in north-central Anatolia, which was occupied but ultimately abandoned. But also a couple of other important sites, which I'll make reference to, Gordian and Kaman-Kalahuyuk, which were not abandoned, neither of which was abandoned at the end of the late Bronze Age. And so we've actually got evidence all the way through into the Iron Age. I'm not going to talk about the detail, but there are data from both sites talking about both environmental conditions, so on-site evidence for environmental conditions, but also of site economies and how they changed. And those data do show continuity in terms of settlement, but also changed economic circumstances for both of those sites. The other thing I'm showing you there is a series of pollen sites, Teje, Ergias, Eskiadjigil, Nar, Supitashu, if that's how you pronounce it, which is a Hittite site where Walter Dörfler has also done a pollen study. I'm afraid most of those are not published, so I'm not going to present them in detail, but I think the point is to make is that there are quite a few records from that part of the world covering the Bronze Age. The other thing I'll just show is the results of a synthesis that my former PhD student, Samantha Alcock, did, and which we published in the latest issue of Anatolian Studies. She didn't do the survey, but she took data from 3 regional archaeological site surveys, one the Japanese survey linked to Kaman-Kalahuyuk, one the TIAY synthesis, and then a third older one by Ian Todd. And you can see the distribution of sites in that area here, central Anatolia, and that's Nar Lake in the middle. So I'll show you some results from that through time too. These are the kind of sites that we can use. This is a particularly beautiful site and informative site where we've done quite a lot of work over the last 15 years or so. This is Nar Lake in Cappadocia. It's still got about 20 meters of water in it, and the nice thing in particular is it's forming these lovely annual laminations or varves at the present day. We've got a continuous record of varves back to 2,600 years ago, that's to say to the Iron Age. Frustratingly, before that, including most of the Bronze Age, the lake, it seems, was too shallow to support stratification of the water and therefore varve formation. So I'm not going to be showing you any detailed results from here, but we do have data emerging, and the data we've got are multi-proxy. So we've got stable isotopes, we've got pollen, charcoal, diatoms, and XRF geochemistry at very high resolution using the iTrack system. So an example of one of the sites of the kind of data that we've got from this part of the world. These are actually data not from Nar. These are the data published a little while ago from Eskiadjigil. The data on the left, the oxygen isotope data, are the curve that I showed you at the very start, but now put onto a vertical axis from 12,000 years ago to the present day. What I've also shown, and it's showing you essentially wet early Holocene, then a drying trend, where these are the cycles that I showed you earlier on. What you can also see there is deciduous oak woodland cover from pollen in the same lake, and we can see a gradual increase to a peak around here. I'm not sure if that peak is particularly significant, but anyway, to a maximum values in the mid-Holocene, and then rather abrupt decline dated at this site to the early Bronze Age. At Nar, actually, we dated a little bit later, probably to the Middle Bronze Age, and then actually rather low levels of woodland cover, of certainly just oak woodland cover after that, so quite a sharp decline. And that decline clearly could be potentially caused by climatic aridity, the climate's getting drier, but it's also very likely to be associated with human impact and deforestation of that landscape. So certainly by the time we get to the late Bronze Age, we've got a climate which has undergone a degree of drying, a lot of oscillations, but overall drier, but also quite a high degree of landscape, in this area at least, of deforestation already having occurred. If we compare that against the regional archaeological survey data, they're not on exactly the same vertical scale, but I'll try and run through it. So this is now the data in black let's get this right, total numbers of sites. The paler is the same thing, but averaged, but recalculated to take account of the different time durations of each period. And I think more interestingly is the red line with the dots. Now that shows, so we're going from Neolithic through to the present day, this shows the proportion of sites in new locations, okay? So what we see, for example, is here in the late Chalcolithic, early Bronze Age, big increase in number of sites, but also a lot of new sites newly founded. Well, it's not surprising. This was, you know, a substantial increase in rural population in central Anatolia. By the time we get to the Middle and Late Bronze Age, however, essentially there is continuity from the preceding late Chalcolithic and early Bronze Age. People are staying in the same place. I'm not saying that things didn't change, but there's no evidence of a major interruption to that pattern. However, once we get to that point, which is the end of the late Bronze Age, the red dot shoots up. So between the late Bronze Age and the Iron Age, there was a major relocation of settlement. There was a major rupture of settlement. So actually, the late Bronze Age, it looks as if it's the last phase of a long cycle of settlement, which began probably in the late Chalcolithic and showed overall continuity up until the late Bronze Age. Then there's a major rupture, and people relocate to different sites, and the cycle starts again sometime in the Iron Age. And again, that then declines through, essentially there's continuity through from the Iron Age into the Classical period, and the next rupture doesn't occur until the mid-Byzantine period. So the late Bronze Age, actually, the end of the late Bronze Age, at this time of climatic aridity, around 3,000, 3,200 years ago, 1200 BC, 1100 BC, turns out to be significant in the longue durée context. In other words, it wasn't just the late Bronze Age cycle, it was a part of a cycle which could be traced back probably 2,000 years prior to the end of the late Bronze Age. That's, I think, quite a significant conclusion. If we take data from pollen evidence, from the cave isotope data, which I'm not going to present here, but there are some from the lakes, as we noted already, the kind of precision that we can hope to achieve, the chronological precision we can hope to achieve with that is probably no better than 1 or maybe even 200 years. However, there are some archives which can do rather better than that. One is tree rings. Now, we have tree ring records for Anatolia running back from the present day about 1,000 years. These are essentially based largely on living trees. For the periods before that, there are no specific dendroclimatological studies. However, as many of you will know, there are quite a number of dendrochronological studies, particularly done by Peter Cunningham. And in particular, the Gordian site, the Gordian timbers, produced important data. Now, these have not been analyzed in terms of past climate specifically. However, and I'm going to put lots of caveats on this, if you take the Gordian tree ring series, there are 3 of them. If you take series 1 and 3, then they overlap in part, particularly for the period between 1600 and 1300 BC. And they show a very similar pattern. So here we've got the 5-year running mean Z-scores for those 2 series. Now, there are a number of factors that could be responsible for that. One is if you have new trees, young trees coming in. However, if that was the case, my sense is you would not expect to see any similarities between the 2 records. So one possibility, and I'm going to, at this stage, only say it's a possibility, and Peter's actually gone off to go and check the data, and I haven't had a response from him as yet in time for this meeting. But if, and there's a big if in there, if those tree rings were controlled by climate variability, then thicker rings would tend to indicate more favorable growth conditions, in other words, wetter conditions, and narrow rings would be indicative of more difficult growing conditions, and in this environment it's likely to be aridity. And if you take the data there, then what we see is quite a marked peak. The amplitude of that peak is probably illusory, but the trend, I think, may be real, is that we see a significant period of enhanced tree growth during the mid-14th century BC, which incidentally was the period when there was some of the maximum expansion of the Hittite empire. And you also see, only in one record, so again has to be treated with caution, the period of narrowest tree growth, which, if it was climatically controlled, starting at the end of the 13th century and running through till about 1140 BC. So I think here we've got a record which, of course, is annual, yeah, and offers, I think, the tempting possibility, and I think it's going to need more analysis, and I don't think this is anything rigorous in the way that dendroclimatological calibrations for the last 1,000 years are, so I think it's much more likely to be semi-quantitative rather than anything which you could attribute to May precipitation, for example. You can't calibrate it in those terms. The possibility that we may have a much higher resolution. And one of the interesting conclusions about that is not just that we seem to find evidence of narrow growth and potentially dry conditions in the end of the 13th century and into the 12th century BC, which we kind of might have predicted, but also this. That's also saying that much of the expansion here was in a period of perhaps 30 or 40 years when conditions were unusually favorable. And perhaps one of the reasons why the late Bronze Age crisis was as bad as it was that previously conditions had been unusually favorable, and that actually encouraged societies to overreach. Yeah? Yeah? If there'd been a more stable condition prior to the 12th century, then perhaps societies might have had a more stable basis in terms of available water resources that was more stable. So that, I think, is intended as for discussion and for potential rather than definitive. I don't think this is something I would attempt to publish at this stage, but I think it is intriguing. So in summary, in central Anatolia, we've got a series of sites like Hattushash, which were abandoned, but also a series of others like Karmankelehuyuk, which were not, but where the site economy changed. We see a large-scale relocation of rural settlements between the late Bronze Age and the Iron Age. The pollen shows that deforestation was already well underway by the late Bronze Age. At a few sites, there's evidence that after the late Bronze Age, we might call rewilding took place, reforestation, but most do not show that. The record that I showed you from Eskiadjigil, for example, doesn't show any return of forests after the Bronze Age. And the climate was clearly variable, some significant wet, dry, and probably warm, cold fluctuations in climate, and probably an extended dry period starting at or just at around 1200 BC. That's central Anatolia. I'm going to move a little bit more briefly to southwest Anatolia, which is also interesting because just as central Anatolia is linked to the Hittites, these are the lands that are known as the Lucca lands, which are also described, we know less about them archaeologically, but which are, the peoples are described in the Egyptian texts and so forth. It's the land of what later became known as Lycia or Lycia. It's a landscape in which there are many lakes. It's the Turkish Lake District. We can see one of them there, Lake Burdur. There are intermontane basins, and it's also, importantly, got the best pollen record of any region of Turkey. There are, I think, 13 pollen diagrams covering the Bronze Age from this region. And that, I think, offers an interesting possibility, not only to look at changes through time, but also geographically. Are you seeing the same pattern of change everywhere? You know, one question, you know, when I present kind of results to physicists, for example, or chemists, they say, oh, it's great you've got that. So how many replicates did you do? You know, oh, well, actually, it takes a long time to do a pollen diagram, okay. I don't look at anything less than 30 replicates, Okay, well, we've got 13 here, so it gives us a bit of a chance to look how representative any one record is. Now, one of the other nice things about that part of the world is that we have within that region a very well-defined, probably the single best defined phase of human land use change anywhere in the Mediterranean for any time period, namely the so-called Beishahir occupation phase. Lake Beishahir is over there, the first site where it was named after by Botimer, Van Zeist and Voldering from Groningen is there at Lake Beishahir. And in the Beishahir occupation phase is characterized by evidence of human transformation of the natural vegetation to make way for agrarian land. So we see crops, for example, cereals, we see pasture indicators, but perhaps the most distinctive thing about it is the use of tree crops. Olive, walnut, manna ash, chestnut, vine, these are very typical of this. So trees and arboriculture was an integral part of the economies that produced this Beishahir occupation phase, which is rather unfortunately abbreviated to the BO phase, or I'll put it there as BOP. And you can see there that of those sites, 5 of them, 3 inland and 2 on the coast, have the onset of the BO phase within the 2nd millennium BC. The other sites have it beginning in the 1st millennium BC. So the onset is undoubtedly time transgressive. In some cases, it begins as late as 300 BC. So starting from probably the Middle Bronze Age through to the Hellenistic period, we see the onset of this phase. And I think that difference is real. But at least 5 sites, it goes back to the 2nd millennium BC. The other thing that's nice, and the yellow squares there show sites which have this, and that is the volcanic tephra from the Bronze Age eruption of Santorini, which Ilko mentioned in his Marine Corps this morning. And these sites, it's not quite as thick as it is in the Marine Corps. Here it's typically 1 or 2 centimeters in thickness. But it's a very important marker horizon, and this improves our reliability by chronologists substantially. It also allows us to do land-sea correlation. The tephra has also been found on a number of archaeological sites like Iassos on the coast, for example. So that helps us. And the distribution of that tephra, you can see basically from the eruption went eastwards and was up to 30 centimeters on the coast, but typically 1, 2, or 3 kilometers as you went inland. Interestingly enough, too, if you take the dendro record as well, and these are data not from Gordian, but from a site called Porsuk from Peter Kuehneholm, what we see is this is the best estimate for the date of that around 1628 BC. You can also see a period of enhanced tree growth, quite short-lived, probably only about 5 to 10 years. In other words, the eruption cooled the climate in this area, probably made it cloudier, and that, in this part of the world, enhances tree growth because, basically it's hot and dry today, and if it's cooler and cloudier, then trees are happier. So we see a period of enhanced tree growth associated with that, not for very long, but nonetheless it seems to be there. We can look at records like this. This is the site of Gürlhisar in southwest Turkey, where we have done some work. Gürlhisar means lake castle, and there is the castle in the lake. It's probably the classical site of Cinder. It's not been excavated, but there's some survey data which suggests occupation from, well, at least the Bronze Age, probably actually from the Neolithic onwards. And there's one of our core sites, and you can see that because the pollen isotope site is close to the archaeology, there's spatial congruence between the two. In other words, if your climate data and your pollen data come from the same place as the archaeology, then you've got high confidence that they can be related to each other. If you're doing it over long distances, I think those possibilities of linkage are made much weaker. Anyhow, if we look at the summary of the pollen, one of the pollen diagrams from here, this is from Warren Eastwood's work, there's the Santorini tephra layer, and then in green is the BO phase. And you can see it beginning probably about 200 to 300 years later than the Thera ash. And if that's dating, if the Thera ash is dating to 1628, then this would date to probably the 14th century, maybe the 13th century BC. But what's also interesting is that it continues all the way through. These are tree crops on the left. It continues all the way through until about 600 AD. So there's no break after the late Bronze Age. There's no rewilding, there's no abandonment. Essentially, we have continuity here, probably from the late Bronze Age all the way through for whatever that is, 1,500 years, a bit more actually, about 1,700 years. If we take other records, so there's the Girlissar record I've just shown you. This is Suyut nearby. There's the tephra. This is Beishir itself, in which the Santorini tephra is not found, but there's an early radiocarbon date. It's another Girlissar record. Then what we see is that in those sites inland, up in the mountains at about 800, 1,000 meters above sea level, we've got probably the onset of this phase occurring in the late Bronze Age and continuing all the way through. So what we have at Girlissar is replicated at several sites. When, by contrast, we move to the coast, although it's only the data are less well dated, nonetheless there is a date, a radiocarbon date, for the onset of that. And the phase, the equivalent phase, is clearly much shorter in duration. It dates it seems, to the late Bronze Age, but then that phase of typical tree crop cultivation and the rest gives way to something else. It gives way to re-advance of the forest with some grasses as well into the after the late Bronze Age, into the Iron Age. So it's based on using statistical zonation of the pollen diagrams. So if you're using CONIS, something called CONIS, stratigraphically constrained cluster analysis, so that defines there. So for example, that phase has typical tree crops in it. You might just, they're a bit hard to see from there, but it lasts from there and ends here. Here it begins there and ends there. Yep, okay.
Okay, so it's not on the course dotted stuff. That's just under the star in Girlissar.
The star simply means a radiocarbon date.
Yeah,
okay.
Under the star in Girlissar.
Yeah.
You've got that course dotted thing. Yeah.
That's an earlier phase. That's something else, which but the BO phase, in terms of its typical description, doesn't begin till there. Okay, so it's I can't remember. It's about 30 centimeters above it. We don't have a precise date for the onset, but the best estimate is based on age depth modeling is 200 to 300 years later. It's not 50 years later. It's not 500 years later. Okay. So we've got a tempting piece of evidence here which suggests that the pattern inland on the coast may not have been the same. And I think that's interesting, because if we then take the record from southwest Turkey and compare it against other published records, obviously we'll hear more about Kinneret in a few minutes, but also from David Kaniewski's work in Cyprus and at Tel Twani in Syria, and those are his data showing decline in crop yields after about 1,200 years ago, and the suggestion that rainfall also declined, is that you can see that at sites which are on or relatively near to the coast, again, we seem to have evidence of post-LBA decline in agricultural land use, whereas at least in some inland sites, especially montane sites like the Lukka lands here, we seem to show greater continuity through from the late Bronze Age into the Iron Age. And I think that's an interesting question. We were talking before about differences between the coast and the interior, and the pollen evidence gives some support to the fact that there may have been those differences. And if so, the whole area would have been affected, not equally, but the whole area, I think we can assume, would have been affected by similar, not identical, but similar climate trends. The one exception to that, of course, is the Nile, is Egypt, because Egypt essentially doesn't receive significant rainfall. What it does get is the Nile flood, and the Nile flood is determined by the Indian monsoon rains falling over Ethiopia. So the climatic control which determines agricultural productivity in Egypt is quite different from the rest of the region and must have buffered Egypt against lots of climate variations. But if we just come back to the other records, then the differences between the coastal areas and the interior might, for example, suggest that non-climatic factors, for example, security near the coast or trade near the coast, may have been the factor that differentiated coastal from interior areas. But it would need more work to test that, but I think it's an interesting possibility. Does climate actually matter for these societies? Well, I think Ilko might recognize this. This is partly based on something which we pulled together at a meeting, and Martin also, in Greece a few months ago. Actually, for most people, both today and in the past, climate is not really sensed. People don't sense climate. We sense weather, yeah, okay? But we also sense climate indirectly through resources like water availability, like crops, like lands, and so forth. And actually, many of our proxies which we use for climate, like paleohydrology, you know, the kind of stuff that Mark Macklin will tell us about, palynology, which will tell us about crops and forests, geomorphology, which will tell us about soil erosion, those which we often transform into climate actually can tell us something about resource availability, which might have been actually much more tangibly sensed by people at the time. And together they form what we might call socio-ecological or socio-environmental systems in which resource availability would have fluctuated through time, as would their management. And because of local variations in climate and relief, being on the coast, being in the interior, the areas where people lived and worked could have meant that the same climate change would have had different impacts for resources in societies living in those different locations. Can we pull this together into something that's a bit more synoptic and a bit more synthetic? Well, one of the things that is notable about late Bronze Age world was that there was extensive trade. But another was that there was clear evidence of military and war activity. There were clearly wars. We know about them. We know about the Battle of Kadesh between the Egyptians and the Hittites. We know about conflicts between the Syrians and the Hittites. We know from the Iliad and the rest that whatever else the Mycenaeans were doing, they were going off somewhere and fighting a war, probably besieging a settlement, possibly Troy, possibly somewhere else. But the point is that there was clear evidence of war activity. And wars use resources. Just as sending armies off to Iraq and Afghanistan today uses resources, that would have been the case in the past. And if we've got resources that are running short, for example, because you've got a drought-induced famine, or because of overexploitation resources, what happens? So what happens if we've got a drought coming in towards the end of the second millennium BC, as suggested from isotope data or tree ring data or other stuff? How does that work? Well, just as earlier on, we had a description of the Ottoman story. I'm going to use the same example, but in a slightly different way. In the period of the Little Ice Age, you had generally a relatively cold and dry climate, it seems, but within it there were periods which were notably more severe than others. And in the NAR stable isotope record, for example, here that's the isotope record which is annually resolved, and these are some diatom data giving backup for that. We've got a period of extended period of drought lasting about 30 years, starting probably in the 1570s and running through to about the 1610s or 1620s. That's also backed up by tree ring data. Those are some data from Peter Cunningham in central Anatolia, and they're also supported by historical documentation. There were famine years, and those were linked to what became known as the Jalali Rebellion. So we've got a well-attested period of drought which had historical consequences. The interesting thing about this is that because we've got good historical documentation, Sam White has been able to trace the chain of connection between drought, agricultural crisis and social unrest, not just to make correlations and inferences in the way that we can for the Bronze Age. And one of the key things about this period was that in the 1590s, the Ottomans were stretched because of military activities far from home. Their armies were on the gates of Vienna, or close to the gates of Vienna. Their supply lines were stretched. They were having to move sheep from Anatolia out to the margins. And it was precisely because their military economic system was stretched to the maximum that there was no spare capacity when that drought struck. And its consequences, therefore, were much more marked than if it had been the case if they hadn't been involved in those military adventures. The same drought 50 or 100 years earlier potentially would have had very different socio-economic political consequences. So climate will have different consequences depending on the vulnerability of the society at the time, and military activity provides one of the ways, and we know that it was the case during the late Bronze Age, that may have reduced societal resilience to drought. And if you've got a situation in which climatic drought occurs, its effects are potentially going to be amplified. Not just because of military activity, but also because by this time we start to see resource depletion. Deforestation, we've got evidence of soil erosion taking place, and potentially those together would have led to water shortages in terms of rivers and springs and so forth. That reduced the range of options from which societies could choose and meant that they became less flexible. And it therefore had a situation in which it strikes me that the late Bronze Age was a society which was immensely successful, but may ultimately have overreached and therefore made themselves vulnerable to climate variability, but therefore also to internal unrest. For example, just as there was a Jalali rebellion in the Anatolian heartland, so potentially there may have been internal unrest within, for example, the Mycenaean world, while their warrior elites were off trying to get Helen back with their 1,000 ships, or whatever. Okay, I'm probably running out of time here, so I'm going to skip the next two, but we can come back to that. Let me just come to some conclusions, therefore. What approaches can we use that might help us better understand those relations? One, I think, is spatial congruence between data sets. I think if we can, it's good to get proxy data for climate and archaeology from the same area. I think we need to remember that cause and effect relations need to be evaluated critically, particularly in terms of dating. There's a very nice term that was put forward of suck in and smear to describe that problem, and I think it's very true. But I think we can improve our correlations by the multi-proxy approach. I think we can do it by using annually resolved archives like VARVs and tree rings, and potentially by tephrochronology, while always remembering that correlation is not causation. And with that, I shall end.